friends. This channel is aimed at extracting the best out of the people. So make sure you like and subscribe our channel and we will make sure that we extract the best out of you. This session is based on rapid calculation techniques for maths wherein we are going to learn the new and rapid techniques for calculations. Now, most of us are using the outdated methods for most of the calculations, right? So, even if it is a small kind of addition, it may take up to 3 to 4 seconds for general addition. But in this lecture, we are going to learn rapid calculation techniques so that we can increase our calculation speeds. This lecture will mainly focus on addition, and the rest of the things like multiplication, division, and subtraction will be covered in a separate video. Now let us begin with two-digit addition, and it is very clear that we are not going to do single-digit addition. Of course, everybody can do 4 plus 3 and 3 plus 4. That's very clear. So now let us take an example of two-digit addition, and let us see how many of us try to solve these kind of sums. Suppose we have two digits numbers. For example, we have 43 and we have 37. So the common approach is to divide this and add the units with the units and the tens with the tens, right? Everybody knows what place value is, so this is the units place. For those of you who don't know what is place value, this is the units place and this is the tens place. So the common approach is to add the units place digits and the tens place digits. While adding the units place digits, let us understand this with an example. The common approach is this: 7 plus 3 is 10. So of course we cannot write 10 together, we'll have to carry 1. So 1 gets carried and 0 gets here. Now the other thing is, while adding the tens digits, what we do is we only add the tens column, that is 4 plus 3 is 7 and 1 is 8. So this is the answer. Now if we follow this common approach, it normally takes it 3 to 4 minutes to 3 to 4 seconds, I beg your pardon, to solve a single sum. But could there be a different approach to solve this question? Let us see. Let us see how we solve this through rapid calculation technique. Now let us take the same sum, that is 47. Oh sorry, I forgot that sum. Okay, let us take another example to solve, that is 47 plus 35. Okay, now is it agreeable that we can write 35 as 30 plus 5? Yes, of course it is 30 plus 5, because this 3 is at tens place, so this is 30, this becomes 30, and 5 is 5. So this is what we call as place value. Now let us understand how we can solve this rapidly. If you have a closer look, if we add 47 to 30, if we add 47 to 30, this 3 is 30. So I'm adding 47 to 30, this will become 77, and plus 5 is 82. So see, in this way you can ease these calculations and do it in mind. So this is the best approach for two-digit addition. First of all, what you do is you separate a two-digit into its tens and units place, and the next thing is you add one two-digit number with other two-digit number and the remaining one-digit number. Let us take another example to understand it better. Okay, so here we have another example. For example, 55 plus 67. Now 55 plus 60 is 115. Okay, 115, and 115 plus 7 is, so what I basically did was I added 55 to 60. Now this is not 6, this is 60 because it is at tens place. So this will be 122. So see, this calculation becomes very rapid with this approach. While if you go by the previous approach, that is to do the same calculation with the previous approach, that is if you are doing 47 plus 37, you need to imagine all sorts of things, that what is being carried and what is not being carried, and this becomes a hefty task for the mind. Whereas if you do it by our approach, that is the rapid calculation approach, that is if you do this, 47 plus 30 will be 77 and plus 7 will be 84. So see, this is how rapid it is. You can also do it in mind, and there's no point where you can lag in these calculations. Now let us start addition of three digits, and we all know what the common approach is. Here in this example we will be adding a three digit number with a two digit number. So let us take an example: 123 plus 34. Everybody knows what the common approach is, so I'll explain it also by the common approach. So what everybody does is they'll add this 4 plus 3, which becomes 7, nothing gets carried, so 3 plus 2 is 5 and 1 remains. So the final answer is 157. Now, is there a better approach to solve this, or say a faster approach to solve this? Let us see. For example, if we take another addition of a three digit number with a two digit number, for example, let us take 123 plus 35. So if we are solving it by rapid calculation technique, so we'll have to divide these numbers into separate these numbers into units place and the rest of the digits. So first of all, separate this units place with the rest of the digits. Now, as you can see, this sum gets separated into two parts. One is 5 and 3, and the next is 12 and 3. Now this becomes very easy. Now, if you have to solve this in mind, you can make a picture of these sums in your mind and separate them, and thus it will become easier to separate units digits with unit digits and the rest of the digits. Now as you can see, these become two different sums. Now while adding, we will add only 12 and 3, and while adding these 5 and 3, we'll add only 5 and 3 because they are now we'll consider them as a separate sum, okay, as a separate part of addition. Now as you can see, 12 plus 3 is 15 and 5 plus 3 is 8. So actually this wasn't very hard. So we'll take a better sum by which we can prove that this calculation is actually a very rapid calculation, which will also aid in a very fast calculation. So now let us take a hard example. Well, nothing is hard, but by hard I mean that something is being carried, okay. So for example, I have 123 and I have 78. So if I separate this, so now these two become two separate sums, or say two separate quantities, okay. So now we'll add 12 and 7 and 8 and 3 separately, okay. Consider this as they have no relation, they are two separate sums, okay. So now 12 plus 7 is 19 and 8 plus 3 is 11. Everybody knows what we do with the excess number, okay. We cannot now, since this is at the unit place, so this becomes 12 and 7 is 19 and 8 and 3 will become 11. Now as everybody knows, there cannot be more than one digit at the units place. So where will this one go? Okay, so we'll add this one here with 9. Okay, so let us see. Now if I carry this forward, it will be 191 and 1 gets added up here. So final answer will be 1 and 10 and 2. Okay, since this is a pen and paper mode, it would seem that the previous outdated calculation is a much faster way to do 3-digit addition with 2-digit addition. But if you try solving these kind of sums in mind, you would certainly see the difference. Now let us take in another example to revise the technique. So let's say we have 556 and we have 78. Okay, so the first thing is to separate the unit digits with the rest of the numbers, and we have two separate sums. So 55 plus 7, everybody knows it will be 60. It will be 62, and 8 plus 6 will be 14. Now, as we know that this only one digit can exist at the unit place, this one will get carried over and get added to 2. So 2 plus 1 is 3. So the overall answer is 634. Now we are going to begin with 3-digit addition. Okay, so we are going to follow the same approach as we have followed in the previous sums, wherein we added 3-digit number with a 2-digit number. Okay, so now let us take an example for this 3-digit addition with the 3-digit addition. Okay, so let us take the first sum, which is 123 plus 123. So the common approach is everybody adds it in this manner: units with the units, tens with the tens, and the hundreds with the hundreds. Okay, so 3 plus 3 is 6, nothing to carry. 2 plus 2 is 4, and 1 plus 1 is 2. So this is your answer. What if we have a better approach to solve these kind of sums? Okay, now let us see what is that approach. Let's say we take 789 plus 298. Okay, now if we follow the same approach, we are going, the first step is to separate the sums into two different parts. Okay, this is a separate sum, this is a separate sum. Okay, so 9 plus 8 is 17. Okay, now as you can see, this sum becomes a part of the first case, wherein we added 2-digit number with 2-digit number. Now this can be pretty simple. 78 plus 20 is, see, 78 plus 20 is 98, and 98 plus 9 98 plus 9 is 107. Okay, so see, now since there can be only one digit at the unit place, will have to carry this one and add it up here. So the final answer would be 1087. Okay, so now let us take another example to understand this better. Okay, suppose we have 999 plus 888. The first step is to separate it into two different sums. Okay, so the unit place will be 9 plus 8 is 17. Okay, and if we follow the first case approach, wherein we add 2-digit to 2-digit numbers, so 99 plus 80 will be 179, and 179 plus 8 will be 187. Okay, 179 plus 8. Okay, so this is 99, this is 99 plus 8 is 179. Okay, so I'll clarify it here. 99 plus 8 is 179, and the remaining part is 8. Okay, so this will be 187. Okay, now since there can be only one digit at the unit place, we'll have to carry this and add it up here. Okay, so this will be 1887. So if you try doing this mentally, you'll find out that this sum is a better approach than the outdated this approach is a better approach than the outdated approach what we used to follow. Okay, so try doing some sums mentally and you'll certainly find the difference. Okay, so here in this we are going to use subtraction for addition. Let us see an example by how we can do this and enhance our mental ability to do addition. Okay, so now let us take an example. For example, we are solving uh, 79 plus 68. What if someone tells you to do it in a fraction of a second? Okay, so the common approach would be to add 9 plus 8 and a very hefty task, that is to carry and not carry, and that becomes a very time consuming task. Okay, so now how do we use subtraction for addition? Okay, so In this rapid calculation technique, let me tell you one thing. Here in this rapid calculation technique, we are using one principle. If you have a look at all of the cases we have studied, we have converted a certain number into a tens place number. Okay, a multiple of tens number. Okay, a multiple of 10. I beg your pardon. In every case we have studied, for example, let us take here we studied in two-digit addition that while adding 97 and 87, what we do is we convert this 87 into 80 plus 7, right? So what we are doing is we are converting a certain number into a multiple of 10 in every case. Okay, not only in this case but in every case. So the same applies here. What we are going to do is, in this rapid calculation technique, we are going to convert any one number into a multiple of 10. Okay, so now let us have a closer look at this. Okay, so let us say we have to add 79 plus 68. Okay, now what can we do to convert? Now let us study with this here. First of all, let us learn to convert a certain number into a tens multiple. Okay, now see, what if we have to convert 79 into a tens multiple? Okay, can I write this as 80 minus 1? Okay, so the nearest tens multiple to 79 is 80, right? And if I add this, if I convert this 79 into the nearest tens multiple, it will be 80 minus 1. What about 68? What about 68? Can you tell me what is the nearest tens multiple to 68? Of course, it is 70. Now, if I take 70, what will I do to 70 to get 68? Right? I'll subtract 2. Okay, so this 68 is now getting converted into a tens multiple. Now what I'm doing here is actually I'm subtracting. Now see what I'll do. Do with this sum. It's pretty easy. Okay, so the first case is wherein we are converting 79, into a tens multiple. Okay, now let us see. If we convert this 79 into a tens multiple, this sum will get converted as follows. This will become 80 minus 1 plus 68. Now you can see it becomes pretty easy to add 80 and 68, right? It becomes 148, and 148 minus 1 is 147. So see, this is how you can ease out the calculation. Okay, so now whenever a number is involved which is near to a tens place, so you can use this approach to solve these kind of sums. Now let us take another example, another case of this sum only, wherein we are converting 68 to its nearest 10. Okay, now nearest tens multiple. Okay, now this sum will get converted as follows: 79 plus 70 minus 2. Now this will become very easy. 79 plus 70 is 149, and 149 minus 2 is 147. So see, this is how you can ease out the calculation. This is how a calculation can be eased. Now another case of this sum only. Okay, further mental ability, or you can say a very good another more simplification of this sum. It could be like this. It could be 80 minus 1 plus another 79. I'm writing it as 80 minus 1, and this will be as 70 minus 2. Now 80 plus 70 is 150, and minus 1 minus 2 is minus 3, which is 147. Okay, so in all the cases I've got the same answer, and this is how you solve a certain kind of sum. Now let us take in another example to understand this technique in a better way. Now these were numbers which had units place greater than 5. Okay. For example, if I take 68, the number at the unit place is 8, which is greater than 5. If I take 79, the number at the unit place, which is 9, is greater than 5. Now what if I take a number whose units place is less than 5? Okay, whose units place is less than 5. Let us see. Okay, for example, if we add two numbers whose units place is less than 5, this will be 71. Let us take an example. For example, if we are taking 71 plus 32. Okay, now what can I write this as? I can write this as 70 plus 1, and this as 30 plus 2. Okay, 32 can be written as 30 plus 2, and 71 can be written as 70 plus 1. Now see, 70 plus 30 is 100, and 2 plus 1 is 3. So the overall answer is 103. Okay, so see, but this isn't an application of using subtraction for addition. Okay, so if we have a look at the previous case, which was units place, the number which have units place greater than 5. Okay, so all in all, we can say that the number which have unit place greater than 5 are actually applicable for using this technique. Okay, so these numbers can be added by using this technique. Okay, so I hope you like the lecture, and we'll continue in the next lecture for subtraction. Thank you.